Back to the chain rule, we're looking at part 4. So we're basically combining rules, and to keep that nice food theme going on, we're blending things. We're making a stew. We're whipping things up here, and so what we're looking at is combination of things. So combinations of chain rule with product rule with power rule, quotient rule, those kind of things. So we're looking at all kinds of combinations, and so to talk about them, I'm going to look at these two examples. Okay, for the first example, basically when I looked at that expression, I'm really kind of seeing two chunks, two pieces that are multiplying. And when I see two chunks, two pieces that are multiplying, two expressions, then I'm thinking product rule. So the overall strategy for this one is we're going to apply the product rule. And then for each of the pieces of our product rule, we're going to do a slightly different thing. So for the first expression here, we do have a parentheses with the power 3 and stuff inside of it. So I'll be thinking chain rule playing with the power rule. So we're doing an overall product rule, but for the first piece, we got chain rule to play with. Now for the second piece, no problem there. It looks like a nice straightforward power rule. Just taking the derivative of 2x plus 12. It's going to be really nice, straightforward, and easy to do. Okay, so that's the basic overall strategy on these. I look at the expression, I kind of see what the overall kind of thing is. I'm seeing two pieces multiplied together, so I'm thinking product rule. So now let's do it. Okay, so when we're doing the product rule, remember that we're doing this F and G thing. So the first piece, so I'm looking at the first part of that expression, and so we call that F. And then we want to take the derivative of that, and I'm seeing parentheses, and I'm seeing a power 3, and I got stuff inside. So I'm thinking chain rule. So I'm doing the outside, so I'm bringing the 3 out in front, subtracting 1 from the power, leaving the inside alone. Don't touch that inside. That's what we've got when we do the outside piece of this chain rule. Now, once we've done the outside piece, once we've done the power 3, then we've got to do the derivative of the inside piece, and that's where you're seeing the 12x squared minus 7. And so their combination there is the derivative of the first part, going back all the way up to this product rule kind of thing. Then for the product rule, we've got the second function, the second part of that expression, and so we call that g. We take its derivative. It's going to be a nice straightforward power rule, and it's going to be 2. And so we've got the derivative of that. So basically what we did was we had the power rule, we had the product rule, and then we took the derivative of each of those pieces, and so now let's put them together. So remember what product rule says? It's f prime g plus f g prime. Okay, so we're doing the derivative of one piece at a time, and so that's what we've got here. We've got the derivative of the first piece, which is a chain rule kind of combination, and leaving that g function alone. And then for the second part of the product rule, we've got the first expression, leaving it alone, times the derivative of the second expression, getting that g prime. And so that's what we have. Now, if you want to, you can kind of expand things out, multiply kind of things. We can factor out too. Looks like we've got this combination of 4x to the third minus 7x squared. We've got, at least we can factor out the squared part, and then when you factor that out and expand it out, multiply, recombine like terms, and that's where I got this from. So you can do some algebra to kind of clean those up. And so there's our example for our first example of combining rules, doing product rule and chain rule together. Now, for the second expression, one of the things I'm seeing here is I'm seeing the parentheses. I got that parentheses there, and I see the power 7. That's the outermost thing. So now I'm thinking chain rule as the main overriding derivative rule. And then when I play the inside, once I start looking at the inside, then I'm going, whoa, I've got a fraction here. So then I start thinking quotient rule. And so that's what I've got. I look on the outside. The main overriding expression is the power 7. And then in the inside, we've got the quotient rule because of the fraction. Okay, and so then when we're doing the quotient rule, remember we're going to be in the steps for quotient rule. We'll be taking the derivative of the top, and then we'll be using a power rule there. And then on the bottom, when we do the derivative of the denominator, do notice that that's an inside-outside kind of thing as well, because we've got a square root, and then we've got stuff inside the square roots. So we'll be doing chain rule there too. So a lot of different rules, a lot of different combinations here. We got chain rule overriding thing with the power rule. Then we've got quotient rule. Top part's got power rule, bottom part's got chain rule. So, and then the power rule within that square root. So we've got a lot of things going on. Okay, so first step is to do the chain rule part, and that was to bring down the 7 and subtract 1 from the power, and leaving the inside alone. We didn't touch this yet. We just left that alone. We're just doing the power 7 and then subtracting 1 to make a new power. And then we still have to do, the derivative of the inside part. Still have to do that. And so here's what we do that. So we realized earlier that we have to do the quotient rule on this. So we've got f of x, the top function we call f, and its derivative, 3x squared. So a nice straightforward power rule there. And then for the quotient rule, we also need the denominator. And so just recall, when doing the derivative of that, we're going to change that square root into a power 1/2. And then when we do the derivative, I got the 1/2, subtract 1, so that's why you see a negative half here. Inside left alone, because it's a chain rule. And then times the derivative of this inside. The 2, remember, is a constant, so its derivative goes to 0. And so we are left with a nice 5x to the 4th. And so that would just be the derivative of the denominator for our quotient rule that we need to do for this inside part. Okay, so we've got all our 4 pieces for the quotient rule. I'm going to do a rewrite of this g prime. I'm just going to put that square root here. It's got a negative power. I'm going to put it in the denominator, and then I'll put that on top, that on the bottom. And so I'm just kind of making this a compact kind of expression. So I'm going to use that when we do the quotient rule. So putting those pieces together, we're going to take the derivative of this fraction. We've got our f and f prime. We've got our g and g prime. Let's put it together as the quotient rule says for us to do, with the f prime g minus f g prime divided by g squared. And so if you may recall that as the quotient rule. And so that's what we've got. If you want to, you can take this and you can simplify. You can factor out a square root of x. Some things will reduce out. And with some algebra, we can get that thing to simplify to this expression here. And so that's what we've got for our result of our quotient rule. And now what we're ready to do is take that and go back and plug it in for this derivative of the inside. We now have what it is. So we've got chain rule. We've got the derivative of the outside, that power 7. We did its derivative, leaving the inside alone, then times the derivative of that inside. And so there's another example of doing very involved type of problems. Each piece we can handle, but it's the ability to look at the original expression and kind of seeing all the strategies, who's inside, who's outside, and how do we put it all together. So I hope this helps, and I hope you got a good idea now of how to do the chain rule. Thanks, and see you another time.